I'm a forester. I've spent 14 years in the forest industry trying to grow more wood in a shorter period of time for the forest industry. And then 12 years ago, I shifted over to the Canadian Forest Service and the Canadian Wood Fibre Centre to do what I trained to do as a master's. When I got my master's degree, was to do research into forestry. And gradually that shifted from growing trees for the forest industry in the forest to growing fiber on agricultural land and incorporating wastewater treatment into that. And my main focus was I wanted more wood. And over time, I became very clear dealing with the municipalities that their interest was broader and they were interested in treating their waste. So what I'm going to start with is just I'm going to give you a little bit of an introduction to who the Canadian Wood Fibre Centre is. We'll talk about the crop characteristics and the requirements because they relate to your site selection. Irrigation systems primarily, but also a lot of what the site characteristics that we're looking for also apply to biosolids application. And certainly there is a large contingent here that's more interested in biosolids, I think, than wastewater. And they're probably much more familiar with the requirements for spreading biosolids on agricultural land than I am, because they're working with it every day. And then we'll just go into some of the fundamental information requirements and where you can find that so that you can feed into the decision support tool that Rick Hurdle, who was presenting later, will show you, because it has some very specific things that it needs to be able to tell you whether you can irrigate or not, and then how much it's going to cost you to do that compared to a traditional engineered solution. So the Canadian Wood Fibre Centre, part of the Canadian Forest Service, we're part of Natural Resources Canada. We have 5 physical labs across Canada and 1 virtual lab. And I belong to the virtual lab, so really I'm not here. What we did is they carved off a set of researchers from each physical lab to work in the Canadian Wood Fibre Centre to work with an organization called FP Innovations to help forest industry identify new opportunities for fiber uses and fiber production. And we deal with the biological side. Eric Phillips will be talking about some of the physical side of things, harvesting and chips, and then there's other divisions used to the old Papricad and the old Form Tech looking at lumber and pulp. We have no responsibility for regulation of wastewater or biosolids treatment. We have no regulatory role in Canada at all. NRCan is an information development group or department. We have no regulatory role. So my interest, like I said, is why I'm working with wastewater is I wanted to produce more fiber, and that's really just how simple it is. So what did that end up? What ended up happening? Well, we ended up installing all of these sites, except Villeneuve, I'm afraid, across Alberta, looking at wastewater irrigation and biosolids. We were interested in growth rates, the fate of the nutrients, application rates, the amount of heavy metals, clonal and species differences, socioeconomic impacts of the treatments, and those are the kind of things we're looking at. And that would not have been possible without the first site being established at Whitecourt in 1996, and that was funded by Alberta Environment and Canadian Biomass Innovation Network. And that demonstration research site led to the installation of the remainder of the sites, and that was funded by Alberta Innovates Biosolutions. And without their generous support, we would never have been able to get to this point. So they're also to blame. And then these are the other culprits in this whole process. None of this is possible, and I think John really made that point. You need a team, you need people working together. We have our municipal partners, and many of them are in this room. We have our irrigation partners. GeoFlow did all the designs, say for Whitecourt, ION for the other sites. We've got our academic partners, Grand Prairie Regional College and U of A. Our industrial partners who provided in-kind and financial support. Benchmark Labs is here today. They provided the chemical analysis for us as part of their contribution. and of course the government departments and the regulators. And without the regulators, participation, specifically Alberta Environment, none of these sites would have got in because they had to be comfortable with what we were doing, because this is not normal for what they usually do with wastewater. So generally, crop characteristics, well, you have to decide whether you're going to grow willow or poplar. We've been working with both because they are the fastest growing woody species in the Northern Hemisphere. This was an international study that was done back in '93, and you can see that willow and poplar rank 1 and 2 for production rates, followed by alder, birch, spruce, and beech. So willow or poplar, they're so close, it's really a matter of choice. Willow tends to be better for biomass, and poplar better for log production. And it's really, that's what your two choices are. Are you just going to produce a whole pile of fiber and you don't care about the dimensions of it, or do you want something more traditional that, say, for Alberta, Ainsworth, they can run through their OSB mill? Some of the general crop characteristics that make these, and you heard some of this yesterday, easy to propagate, so it's just greenwood cuttings, easy to establish. You put them in the ground and they'll develop shoots and roots right from those cuttings. For the willows and for the poplar for biomass, they resprout very vigorously after each harvest. That's good from a biomass production standpoint. It's also good because they're always in a juvenile growth phase, so they use a lot of nutrients and a lot of water, which is something we want to do. A high potential for genetic improvement, and certainly when John and I were out yesterday, we really saw the implications of what a certain clone can do on one site and what it can or can't do on another site. So there's opportunities to select individuals or breed plants to do different jobs and to grow different and to adapt or be better suited to a particular site, whether that's soil or water or whatever. And right now we also have quite a few varieties available. It's just a matter of matching them to the site and to their end use. Some other good characteristics for the crop are the extensive root system. So when you have this 80% of your root system in the top 30 centimeters of the soil profile, you have this web of roots that are not going to let a lot go by them in terms of nutrients or water. So another plus. Long growing season. So now we're getting into the willows more. The others apply to both species, or both genii. Long growing season. Willows starts one of the first to start in the spring, the last to shut down in the fall. So that's good for water use. Ability to take nutrients, we talked about that. High evapotranspiration rate, great if you're trying to process a lot of water. If you're water limited, it might make it a little bit more challenging to grow it out of its optimum range where you've got where you need precipitation to meet your water requirement. And ability to accumulate target pollutants. So you have contaminants, some heavy metals, cadmium, nickel, and zinc are preferentially picked up by willows. You can use the willows to pull those things off your site. So willows are found on a wide range of sites. You have pHs of 5.5 to 7.5, perfectly to moderately well drained. So it's not really soggy and not dry. Sandy loams to silt and clay loams, so that's a pretty broad range, but it tends to be more on the finer side than say, poplars. And if you're only relying on precipitation, you really need about at least 450 millimeters, or 20 inches of rain a year to keep them going. And like any crop, better soils will give you greater yields. And greater yields, faster growth, more nutrient uptake, more water use. Poplar, same thing, found at a wide range of sites, same pH, same moisture requirements. A little sand, you can go to a little sandier sites, a little more coarse textured. Can work with a little less water, but that also is very clonal dependent, as it is with the willows. And EC, so electrical conductivity, the estimate of salt in the soils from 0 to 4. We just did a study looking at some oil sands processed water with willows. We screened 75 willows, and they were at ECs of over 3.6, and some made it and some didn't, and some didn't care at all. Whether it was low EC or a high EC, they performed the same. So again, there's opportunities to select and apply different clones to different jobs. and better soils, again, produce greater yields. So let's talk about some of the irrigation systems, because you've got to understand what your options are. We have not been working with any kind of sprinkler system. We decided not to go that way for two reasons. One is having to deal with risers of any type in terms of harvesting, and so any kind of a tube coming up with a sprinkler head on it. The second one was we were concerned with production of aerosols. When aerosols are going to get smell. And our first location at Whitecourt was right beside the baseball diamonds in the town, and there was a concern by the regulator for the odor and also for human contact. So with subsurface drip irrigation, you're burying the line 12 to 18 inches underground, and these emitters are every 12 to 24 inches depending on the spacing you want, and the water comes out of that hole and it never sees the surface and is right in the root zone where the plants can use it. Very easy to put in. Our contractor that we've been working with, Design Irrigation, built this multi-unit insertion tool. We can do anywhere from up to 6 different lines at one time, so that increases production and lowers costs. And you can see in the right-hand photo basically you just have to put in some piping and insert the tool. So some of the insert the line. So the advantages are reduced incidence of mechanical damage, say to mowers. You're not going to get any kind of rodent damage, like from this monstrous beaver that they trapped up in Beaver Lodge. That would chew up a surface line like spaghetti. So the disadvantages are it costs a little bit more. There's more challenge if you're replanting the crop because you're dealing with a buried line, and then removal from the field if you're returning the field to a traditional crop. So the other system, this is the system that John Gilberts has been using, and I've seen it in operation, and it's one that we're going to install at O'Hatton at our Camrose County site. Basically an 1.25 inch line with holes drilled about every 10 meters, and I won't get into all the details, but basically with that hole you put this plastic sleeve on that hole, and that sleeve keeps the water from going up like this and just out to the sides, and you get this pool of water as you see in the right-hand photo here. Sorry, left-hand. Just this little pool of water that works its way over the surface and soaks in and spreads out over time, and you adjust your watering interval or your irrigation interval so that you're meeting your requirements of your crop without overdoing it. The nice advantages of this is you can always see which one's working, which one of these holes might be plugged. You can't see that in the subsurface drip. You can detect it in the subsurface drip, but you don't know exactly where it is. I've seen this working on slope. What's the slope of that one field in for? Considerable, and there was no problem with surface water coming down. They had a creek at the bottom, and there was no detected nitrates or other nutrients in that creek. This system works very well and should come in at a significantly lower cost than the surface, and we'll find out when we actually do the installation in the next couple of months.
You meant underground. You said surface.
This one is that one.
The underground is more costly than the surface.
That's right. That one should be cheaper, but it's got the disadvantage of it is that it's on the surface. It's subject to mechanical damage. It's subject to rodent damage. So those are other issues that have to be dealt with. So there's some other infrastructure involved. There's pumps. There's filters. So the pump is sitting in here on this platform. Filters. We bury our lines. I know John's running his lines on the surface along the fence lines I've seen on some of his fields. You've got valves and you need a control system. But all of these factors are taken into account in the costing that's going to come out of the decision support tool. So we've built a couple of models to help with that process of giving you an estimate of what it's going to cost to put in either a surface or a subsurface system, given certain parameters for your site. We did do some work in biosolids. I'm not going to spend a lot of time on this, but we did build a injection unit. So we have a tanker, and then this head that was injection head that was built. Unfortunately it's attached by a pin hitch to the tanker. The tanker is attached by a pin hitch to the tractor, and then when we were pulling it through the field, not everybody lined up all the time, and so we're kind of sliding from side to side. Every once in a while to take out some trees. The other problem we had was when we did it, it had to be the wettest spring we've had in a while, and every time we had the guy lined up to do it in June when we wanted to do, it rained and he was delayed at another site, and then so we ended up doing it in August, and by that time the trees had gotten tall and we were bending trees. It wasn't a pleasant sight, but we had to do it. And we learned a lot, and I think this is a good way to go, but it's going to need some modifications to make it more effective. So let's get into the information requirements. I'm going to take more than 15 minutes for my talk, so maybe 20?
Okay.
Maybe 25?
I'll stop you at 30.
Stop me at 30. So there are several sources in Alberta of information that you can go to find out what's required before you could irrigate or apply biosolids. The people that work with sludges probably very familiar with that. The irrigation manual gives you details of what the limitations on water and soils are, and then this manual talks about the site characteristics and whether or not your site is suitable for irrigation. So I'm just going to, it goes into a lot of detail, and it would have made for a very boring presentation if this isn't already. So I'm just going to pull out the highlights that really relate to what you have to get to put into the decision support tool. There's all sorts of details on sampling and who does it and whether you're qualified. That's all in the manuals, and you can get that information for yourselves. The first thing when we were looking for partners for this project, and people approached us, is we go out and sample the lagoon. This is for irrigation. Because if the water didn't meet some basic chemistry, then there was just no way we would even try approaching Alberta Environment with an approval to go forward. So the first one was electrical conductivity. So basically, it's an indicator of the salt content in the water, and just for a point of reference, you have to have a EC of less than 2.5 decisiemens per meter, which is the unit of measure to irrigate. Anything over that, and you wouldn't be allowed to put it on your field. We actually were working with willows that had ECs of over 3, and there are willows that will grow in those kind of conditions, but that's just a point on the side. The other element is sodium absorption ratio, which is the amount of sodium relative to calcium and magnesium in the soil. And sodium, it causes several problems. First of all, it's toxic to plants. And the second one, it really mucks up your soil physical properties. And so if you're going to take high SAR water and put it on good soil, eventually you could damage that soil unless you manage. You have to manage it a lot more closely, letting the soil rest, or really flooding the soil and letting precipitation then take some of the salts deeper into the soil profile. There's ways of managing this. SAR has to be less than 9, otherwise you will not be allowed to irrigate. There's several other parameters that come into play. There's BOD, TSS, COD. The definitions of the acronyms or the words for the acronyms are up there. Biological oxygen demand under 100 milligrams per liter, total suspended solids under 100 milligrams per liter, and pH is a 6.5 to 8.5. So the pH is not a problem for the willows. It's starting to get on the high side, and it might start locking up some nutrients in the soils, but it also depends on your soil characteristics. Usually it was the first three, or actually the EC and the SAR, that were really the first indicators. After we got those through, then we would check for the others. Any of the labs that are now testing your water before you discharge have the capability of doing these other tests for you. There's also the issue of site selection. Where is the field relative to your lagoon, where your crop is going to go, and where is your crop relative to where you're going to be using it? This is the site at Beaver Lodge. Town gave us access to their lagoon. This is PRT's nursery at Beaver Lodge. PRT is the partner that gave us access to their land. And no man's land in here, we had to cross with a pipeline, a 500-meter pipeline, to get the water from one site to the other. So this obviously is a more expensive installation than one where your lagoon is 20 or 30 meters from where the field you're putting it into. The other thing is, you have to do something with the crop. So if your crop is here and your closest user is 50 miles or kilometers away, then that's going to change some of the economics for you than if you're actually using it here in the nursery or in the town, which is less than 5 minutes drive away. Some of the other issues, and these are in the regs, is your distance of your site relative to other features on the landscape. So this is didn't turn out very well. This is the Owhatton site in Camrose County. The lagoon is here. Our irrigation site is here. So the first questions from Alberta Environment is, are you 15 meters from the adjacent property lines? Are you 60 meters away from occupied dwellings? Are you 30 meters setback from water courses, public roads, railways, lines, and water wells? There's no formal requirement in legislation for pipelines, but originally, and much to my great embarrassment, I wanted this piece of ground for the site, and the town started negotiating with the landowner for that piece of ground. And then I found out that there's 5 pipelines underneath that piece of ground. And when you're talking to the pipeline owners, some wanted 1 meter clearance from their right-of-way, other ones wanted 10 meters clearance from the right-of-way, and eventually we basically would have had nothing left to put the lagoon on, or to put the crop on, or the irrigation field on. So we ended up having to put it over here. Not my preferred location, but it is working quite well, and there's some interesting things happening there from a research perspective that is going to give us a lot of information on how we deal with solonetic soils, and that's what this site is. It's on a solonetic soil. So that means it's got high sodium in the soil, it's high SAR. There's also a few other requirements. They're more related to the biosolids, but depending on the regional engineer we were dealing with, we were held to some of these. 200 meters from schools, 200 meters from cemeteries, playgrounds, parks, and campgrounds. Some wanted groundwater sampling wells, other ones didn't want groundwater sampling wells. All of these things come into play when you're deciding on where you're going to put this. So that's why you have to be discussing this with your regional engineer or with your regulator, so that you don't get caught out with one of these parameters hampering your site selection. A few other things, infrastructure. Because we're dealing with lagoons, they never required any power. This is all passive treatment systems. And so we had to put in power lines. So this is, again, the Beaver Lodge site. So there's a $10,000 three-phase power line that had to go in from there to there, just to be able to pump water up into the field. The same thing with Claremont, the same thing with Owhatton. All had to have power lines put in. Some are single phase, that really doesn't matter, but the thing is, that's something you've got to consider. Where are you relative to your road access? Do you have good road access into your lagoon, or are you crossing in some farmer's field? Because you've got to be able to get planting equipment in there, you've got to be able to get harvesting equipment in there, and you've got to be able to get your crop out of there. And then the other issue is the size. Are you shooting for a certain amount of biomass? And how big does it have to be to produce that? Are you shooting for treating a certain amount of water? How big does it have to be to produce that? You need to have area around your planted trees so that you can maneuver equipment. So here's our fence line. This is again Ohatton, and we've got 15-meter headlands here so that we can turn harvesting equipment, planting machines, and things like that when we're actually going to be we're managing and harvesting the site. So that also, you have to consider how much space you need for the crop so that you can manage it. So there's the assessment manual. So we're down to the last strokes here. In that, I'm just going to back up again. So in this manual, Procedures Manual for Classification of Land for Irrigation, it requires these parameters in a determination of a factor or a number that ranks your piece of land for suitability for irrigation. And Rick Hurdle has incorporated these parameters in the decision support tool so that you just pick what you have on your site, and then it calculates the rating for you. This information isn't as hard to get as you think. There are lots of tools that have been built by both the federal and provincial government to help you with this. One of them is this one. This is the Crescent Sites at Alberta Agriculture Rural Development. It's the Alberta Soil Information Viewer. This deals with the white zone in Alberta, so the agricultural land zone if you're not from Alberta. And you can go in this system, and we're going to use Camrose as a guinea pig again for the demonstration. And you can enter the range and township, your legal description, or you can actually go through and bore down through the map, and you pick your site. And on here, the blue here is the lagoons at Ohatton, and you can see we're in this soil classification zone, and there's the polygon number, and it tells you what the soil types are, what the drainage is, and actually it'll even generate a nicer report for you that tells you you're now in a solidized solonets, and part of the soil it's a black charnism, and it's a loam or a clay loam. So those are the kind of things you can put in to the decision support tool. And if you're an older guy like me and you still like working with paper, there are the old soil survey reports for Alberta. Actually, they're available for every province. They were done by Agriculture and Agri-Food Canada, and they're the old paper reports, and they look like that. You might even have them in your library. And so we're going to use Virolodge as the example here. And so, and everything's in PDF, so you can just zoom in. That's all I did, and did a screen cut. So there's the lagoons at Virolodge. The town's right here. So you can see we're in an LAAB soil type. And then we go to the legend. You can see that LA is a black soloid, silt loam, clay loam, and the AB is a dark gray soloid, loam, clay loam. So you can pick one of those or two each time and run it through the model and see what it tells you. It tells you it's so there's your geological deposit, and you've got your soil texture. So there's the information that you need to do that. The only thing that it's not going to give you is the SAR and the EC. You'll have to take soil samples and run it to the lab, your favorite lab. Benchmark Labs is a good choice. And they'll give you those kind of figures that then you can put into the model. And those costs aren't that great, even just to get a preliminary idea of whether the site is suitable. If it is suitable, then you're going to need more expertise to help you actually go through the process of classifying that land as a certain way of sampling and stratifying the plot to get it to work out for you, or to get the information you need to be able to determine whether you can irrigate it. So, in summary, you have to ask yourself, what am I going to do with the fiber? You just can't. It's not going to stay on the site forever. If it's going to be biomass like willow, you have to harvest it every 2 to 5 years, because otherwise it just goes to the point where you'll have a very difficult time getting it off. It just gets too big, given the densities that we plan for that. And I think John will talk more about that. You'll see what the difficulty is there. You have to test your wastewater. You have to consider is there suitable land close by, and you should be working with your regulator right from the beginning in deciding whether or not this is an option for you.